All right, welcome back to our unit here on chemical reactions. Today's topic is precipitate reactions, reactions that form a solid. Okay, lesson 3 of 3, your objectives are as follows. To learn what a solution is, to learn the difference between soluble and insoluble, to understand how a precipitate forms, to learn how to predict the solubility of a substance using the solubility rules. Okay, feel free to pause this video anytime you feel necessary. Okay, for your quick write, what do you think happens to table salt, sodium chloride, when you pour it in water and stir it? Think on a molecular level. Calcium phosphate is what your bones are made of. Is calcium phosphate a solid? Does calcium phosphate dissolve in water like table salt? Okay, sodium chloride. And then what do you think is the difference between the terms soluble and insoluble? Okay, go ahead and pause this if you need more time. I'm going to move on. All right, solutions. A solution is a mixture of water and a dissolved solid. For example, if you were to pour sodium chloride, table salt, into water, the atoms dissolve and disappear, creating a sodium chloride NaCl solution here. Okay. Notice in a solution, the ions have separated here and move around freely in water. Okay. So for your notes, what is a solution? Question on the left-hand side. Okay, answer on the right-hand side of your notes. Go ahead and pause this while you write. I'm going to move on. All right, so precipitate reactions, reactions that form a solid. Many chemical reactions occur in water. Okay, virtually all of the chemical reactions that keep us alive take place in the aqueous or liquid body. Okay, for example, the oxygen you breathe dissolves in your blood and is transported to vital organs so it can carry out more important chemical reactions. Okay, one type of chemical reaction that occurs in water is a precipitate reaction. Okay, precipitate reactions result in the formation of a solid or precipitate in solution. Okay, so the actual solid that forms from the reaction is called the precipitate. In this picture, the white solid over here represents the precipitate or solid. Okay, so in a precipitate reaction, the cations and the anions essentially just switch places when two solutions are mixed together. So, like I just said, precipitate reactions take place in water when two solutions are mixed. Okay, so consider this reaction here. So, consider a sodium chloride and silver nitrate solution below here. All right, notice the ions from each compound separate, or we say dissociate, break apart, and dissolve, and then float around suspended here in water. Okay, so we have two solutions here. So like I said, two solutions, a solution of sodium chloride, all right, and a silver nitrate solution over here. So, but what happens when these two solutions are mixed? Okay, well, let's find out. Okay, let's take our sodium chloride solution and move it on over here to the silver nitrate solution. Okay, notice the ions, all of the ions are mixed together, all right? Notice silver and chlorine here linked up and bonded. So when mixed together, the silver cation bonds with the chloride anions, forming a white solid or precipitate here. All right, so silver and the chloride anions and cations got together here and formed silver chloride, a white solid. After the white solid forms and sinks to the bottom, the sodium and nitrate ions are still left dissolved in water here. Okay, they are aqueous. Okay, so it is important to realize that once the two solutions were mixed, the ions basically just swapped or switched positions with each other, creating the white solid here. So notice, when they were in solution, they were dissolved as ions. And then when they mixed together, they essentially just switched positions here. Okay, and AgCl forming the solid and sodium nitrate here is still aqueous, dissolved in water. All right, so for your notes, what is a precipitate reaction? Question on the left-hand side, answer here goes on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, so soluble versus insoluble. The term insoluble describes a chemical compound that does not dissolve in water and remains a solid. The term soluble refers to a chemical compound that dissolves in water. Consider our last example below, where two solutions, a sodium chloride solution and a silver nitrate solution, were mixed together, forming a precipitate here. All right. Well, if you recall, this reaction formed a solid. The solid was silver chloride, AgCl, as a precipitate. So silver chloride is a compound that is insoluble in water, meaning it does not dissolve in water and remain a solid. All right. If you further recall, sodium nitrate is aqueous and still remains dissolved in water. Therefore, it is a chemical compound that is soluble in water, aka it will dissolve in water and remain aqueous. Okay. So for your notes, what's the difference between soluble and insoluble compounds? All right, question on the left-hand side, answer here goes on the right-hand side. All right, go ahead and pause this while you write. I'm going to move on. All right, so solubility rules. In order to determine if a chemical compound is soluble, it will dissolve in water, or insoluble, it will not dissolve in water, chemists use a set of rules known as the solubility rules. It is important to note that solubility is a relative term because some chemicals will dissolve better than others. Okay, the solubility rules are important guidelines, though, that will allow us to tell whether a chemical compound is either soluble or insoluble. Earlier we learned that silver chloride was insoluble in water and sodium nitrate was soluble in water. In this case, the solubility rules allowed us to determine which chemical was soluble and which chemical was insoluble. For example, if we apply the solubility rules to silver chloride, AgCl, we can predict whether it is a soluble or insoluble compound. In other words, will it dissolve in water or will it remain a solid? Okay. So notice silver chloride has the chloride anion Cl-1 in it. Okay, well, you got to find that on your solubility rules. Okay, according to our rules, all chemical compounds, containing chloride are soluble. In other words, they will dissolve in water, except though when bonded to Ag+1, lead +2, or Hg, mercury +2 here. Okay. And as you can see, silver +1 is one of our exceptions here. All right, so silver is an exception. So if silver is bonded to chlorine, it's not soluble. All right, so we say AgCl is insoluble in water and will remain as a solid or precipitate because silver was one of our exceptions to the rule here. All right. We can also use the solubility rules to determine if sodium nitrate is soluble or insoluble in water. Okay, notice NaNO3 has the nitrate ion in it, on our rules here. So find the nitrate. Well, according to our rules, all compounds containing the nitrate ion are soluble, no exceptions. Okay, so therefore we say sodium nitrate is soluble in water and will remain aqueous or dissolved in water. Okay, so for your notes, what are the solubility rules? Question on the left-hand side, answer on the right-hand side. Okay, you don't have to write this down. All right, I will give you a handout. So go ahead and pause this while you write. I'm going to move on. Okay, so for your notes, practice here. Using the solubility rules, determine whether each compound below is either soluble or insoluble. Okay, so use these rules and write either soluble or insoluble next to them. All right, go ahead and pause this while you work on these problems. Hit play when you're ready to see the answers. All right, so calcium carbonate. Calcium carbonate is what shells and corals is made of, and we know those won't dissolve in water, but nonetheless, we can still use our rules here. So calcium carbonate is insoluble based on our rules. So find carbonates. Okay, here's a carbonate. Carbonates are insoluble, and calcium is not one of our exceptions, so it is insoluble. All right, lead bromide. All right, lead bromide is insoluble. Okay, find bromides here, and notice lead is one of our exceptions, so bromides are soluble unless bonded to silver, lead, or mercury. In this case, it's bonded to lead, one of our exceptions, so it is insoluble. All right, so next one here, sodium sulfate. Well, it's soluble. So all compounds containing the sulfate ion are soluble except when bonded to barium, calcium, strontium, silver, lead, and mercury. And notice, sodium is not one of the exceptions, so it is soluble. All right, and the last one here, potassium nitrate. All compounds containing the nitrate ion are soluble, no exceptions. Okay, so we don't have any exceptions to worry about. So if it has the nitrate ion, it is soluble. Okay, hopefully you did pretty good on those. Feel free to go back and try again. Okay. All right, so writing precipitate reactions. The last thing we're going to talk about is how to write precipitate reactions here. It is important to realize that most, if not all, precipitate reactions occur in water. All right, so consider the two compounds below, sodium hydroxide and magnesium chloride. Okay, when placed in water, these compounds can dissolve into their respective ions. Okay, so when they're in water, they're in their ions here. Okay, aqueous form. In doing so, the cations and anions are able to switch positions, and it's possible to form a precipitate here. Okay, one of the things you will be required to do is to write and predict the products that form from a precipitate reaction. Okay, so when these two were mixed, these two solutions, which one here formed a precipitate? Okay, using your solubility rules, you will also need to determine which compound is soluble and which compound is insoluble. All right. So using your solubility rules, you can see here that magnesium hydroxide is the solid here, or precipitate, indicated by that S, right? Which means it's a solid. All right, so practice, okay? Before you try doing these on your own, listen, the precipitate reactions here below occur in water. So write and predict the products for each reaction below. Determine which compound of the two products will form a precipitate or solid. Okay, if you can, underline the precipitate and use the symbols AQ for aqueous and S for solid. Okay, a couple suggestions here. When you do this, swap the cations and anions first. Okay, and then write the formulas using your ionic nomenclature rules. In other words, make sure each compound has a neutral or zero charge. And then balance the reaction last. So go ahead and pause this while you do this. Okay, so predict the products here. And then hit play when you're ready to check your work. Okay, so when mixed together, all right, you get potassium chloride and magnesium hydroxide, which is our solid or precipitate. And when you balance it, okay, you get 2-1-2-1. All right. Finally, the last equation here. Okay, when these two solutions are mixed together, a solid forms, which is our magnesium sulfide here. All right, and when we balance it, all right, you get 1-1-1-1. Easy one to balance. Okay, hopefully you did pretty good on those. Feel free to go back and try those again if you think you still need more practice. Okay, if not, all right, let's go ahead and summarize here. Explain what a precipitate reaction is and how precipitates form in water. Compare and contrast the terms soluble and insoluble. Okay, and then write down two compounds that are soluble and two compounds that are insoluble based on your rules. All right, what do we use the solubility rules for? And then finally, what are some steps or suggestions you should follow when writing and predicting the products of a precipitate reaction? All right, so go ahead and pause this while you finish your summary, and we'll see you next time.